Problem 18, page 141. Here we have a bag of cement of weight. We have the weight F, or we can say W, equals to 325 Newton. Hangs from 3 wires. We have 1, 2, 3 cords. For each one, we have T1, T2, T3. As you see here, between this one and the top, we have the angle theta 1, and between T2 and the top, we have theta 2. The angles theta 1 equal 60 and theta 2 equals to 25. Now I have to find the tension T1, T2, and T3. And the important here, that if the system is in equilibrium. What I mean that the summation of F equals to MA equal to O. Okay, it's important because it's in equilibrium. Okay, you know that I'm talking here about Newton's law. We have to apply F equal MA. And okay, let's say here we open a new page. Here we have the object tension T1, T2. First of all, I ask you to draw free body diagram. I mean, I have to draw all the forces on the object. Okay. Let's say here we have this chord. Here we have T1 and T1, the same magnitude, like this. Here we have T2 and T2. And at this point here we have, let's choose, here we have T3. Okay. And down, what we have on the object here we have the weight downward, and we have the tension with the same chord. Here we have T3. Okay, so T1, T1, T2, T2. Okay, T3, T3. Don't forget the vector. You know that here, okay, we have here mg. Okay. Now, as you see here, we have to calculate T. First of all, I have two systems here. The first one is here. We have this object, mg T3. We can apply Newton's law. After, we have here a second system, this one. We have T3 down, and we have T1 and T2 with the components. Let's say here system 1 and here system 2. We begin with system 1. The summation of F applied on the object of the bag of cement equal M times A, equal to O, because it's in equilibrium. Okay, In function of fx, we have no forces because we have nothing in this direction. We have only in the y direction. Okay, so nothing. Okay, anyway, I like to write like this. Fx and Fy. Here we have nothing about Fx, but about Fy. What we have, T3 it's up, so T3j. Mg down, so we put its magnitude and minus j. Okay, equals to O. So T3j equal mg j. We can cancel j because we are in the same direction. So T3 equal m. Mj, you know, we have the weight of the object equal here equal mj. Okay, equal 325 Newton. We calculated the value of T3. Now we come to solve the system 2. In order to calculate T1 and T2, we had calculated the value of T3. Okay, we clean this one and we begin with this one. Here, be careful. You have to draw, first of all, the x-axis and y-axis to know the components of each one. So here we put x and y. X and y. You know that for each one, F2, it's red. We have a T2. T2 has T2x and T2y. Okay. Let me clean here this one like this. Just like this. Okay, T2 like this. And here we have T2x and T2y. The same for T1. Blue. Here we have T1x and T1y. T1x, T1y. Excellent. By corresponding, this one, the angle equals theta 2, so this angle equal theta 2. Okay? This angle equals theta 1, this one equal theta 1, because we have two parallel lines, and like this. This angle must be equal this angle. And the same for this one, like this. This angle equals to this angle. Okay? We come back. Now, I want to calculate the summation of f on the object. Summation of f equals to 0 in equilibrium. What we have here, we have on the system, we have T1 plus T2. and we have T3 down, so plus T3. We know that T3 in the Y direction, so T3 equal T3Y, okay? It doesn't have X component. So we can say T3 or T3Y is the same, okay? Equal to 0. Okay, now I write in function of I and j. T1x in the negative direction. So we write T1x minus I. T1y up, okay? So T1yj. T2x is to the right. T2xi, T2y up, so T2yj, T3y is down, so minus T3yj equals to 0i plus 0j. We don't have a. Now we take I, and I. We get minus tx I. We don't need to write I. Plus T2x equal minus T1x plus T2x equal to O. Okay, so Tx equal T2x. We come here to here we have one. To Tx, we take this triangle to calculate T1x, this one, like this. You see well that T1x is adjacent to theta 1. So by cosine, we calculate T1x. So here we can write T1x equal T1 cosine the angle theta 1 60 equal. We have here, okay, you put T2x this side, you will get minus minus, and we get this relation. T1 cosine theta, T2x, we can calculate by using this triangle. T2x is adjacent to theta 2, so T2x equal T2 cosine the angle theta 2 25. So T1 must be equal to T2 cosine 25 divided by cosine 60. Okay, this is the value of T1 in function of T2. Equation 1. Equation 1. We use the y components. We have this and this and this and this. We can write here T1y plus T2y minus T3y equal to 0. T1y is up, T2 is up, T1y is opposite to theta 1. So by sine, we can say T1 sine sine theta 1 equal T1 divided by T1. Sine theta 1 equal T1y divided by 1. So T1y equal T1 sine theta 1 60 plus the same for T2y is opposite to T2, to theta 2. Sine theta 2 equal T2y divided by T2 in this triangle. So T2y equal T2 sine theta 2, which is equal to 25, minus T3y equal to T3. Okay, we don't have x component. We can say T3 equal to 0. So T1 equals to T3 to this side equal T3 minus T2 sine 25 divided by sine 60. Okay, you know that T3 we calculated its value, which is equal to 3 to 5. We get this equation also, the value of equation 2, the value of T1 in function of T2. You have equation 1 equals to equation 2. So 3 to 5 minus T2 sine 25 divided by sine 60 equal to T2 cosine 25 divided by cosine 60. Listen, if you want, you can keep one equation with T1 and T2, and the second also T1 in function of T2, and by using your calculator, you can calculate the value of T1 and T2 directly. Okay, you can do it. So now we can calculate easily T2, which is equal to 163 Newton, and you substitute this value here. For example, you get T1 equals to 296, and this is the answer. T1, T2, and here we have T3. So the most important point here is to apply Newton's law on the object. First of all, you have to put x and y, and you illustrate the components of each f. You have to put fx, fy, tx, ty to each value. When you have the xy components, it's easy to write these components in function of I and j. You get finally two equations in function of x and y. You get finally two equations with two unknowns. Like this, it's easy to solve any problem.